Okay, in this video, we're going to talk about absolute value inequalities. So first we need to review what absolute value means. And if you recall, if I wrote the absolute value of 5 or the absolute value of negative 5, those are both equivalent to 5, because what that means is how far is 5 or negative 5 away from 0. So if I write those on the number line, from here to here it is a distance of 5 from 0 to negative 5, and also the distance from 5 to 0 is also 5. Now typically we don't write in the 0, but really what we're doing is we're writing it like this, even though we don't write the 0 in, because we're saying what's the difference between the 5 and the 0. So now if we look at example 1, we want to describe all the x values within or including, that is a distance of 4 from 8. So we want to describe, if we look at the number line, if I look at the number 8 on here, all the numbers that are within a distance of 4 from 8. And it says to also include the distance of 4, whatever that number is. So if I come out 4 this way, 4 from 8, that's 9, 10, 11, 12. And then if I come in the other direction, that's 7, 6, 5, and 4. And then, of course, all the numbers in between. So anything between 12 and 4, including, because it says here, including 12 and 4, are numbers that are within a distance of 4 from 8. And the way we would write that would be like this. So this means any number x that's within 4 of 8. Now we can look at it on the number line to figure it out in this next example. This is saying I want to find all the numbers from 3 that are within 4 or including 4. So I want to go 4 out this way. And I want to go 4 this way. So that would be including 7, including negative 1, and all the numbers in between, because this is the distance of 4, and this is the distance of 4. And anything within that is less than 4 or equal to 4 away from 3. Now, if we want to solve this algebraically, the way we would do this is we would first isolate the absolute value, which that is isolated, and then we're going to set up two separate inequalities. Okay, so the first inequality, we're going to take what's on the inside, which is the x minus 3, and write less than or equal to 4. The second inequality, what we're going to do is we're going to switch the direction of the inequality sign and then change the sign of the number that's on the right. And then we're going to solve each of those individually. So for this first one here on the left, I'm going to add 3 to both sides. And then for this one here on the right, again, I'm going to add 3 to both sides. And so I get x is less than or equal to 7 and x is greater than or equal to 1. Now, when I look at that on the number line, and I graph each of these individually, let's graph this in red. So here's 7. Anything less than or equal to 7 means I'm going to fill in 7 and go to the left. Let's do this one in blue. Anything, whoops, it looks like I forgot my negative. Okay, so anything greater than or equal to 1 will go this way. This is definitely an and statement because they overlap. Now, where they overlap will be the answer. So it overlaps here to here. So when I write down my interval notation for that, it would be negative 1 to 7. And if you look, that matches what we have here, all the numbers between negative 1 and 7, including negative 1 and 7. So we can look at this on the number line, try to figure it out first, and then we can solve it algebraically to make sure that it matches up. Okay, in the next one, first we have to isolate the absolute value. So I need to subtract 1 and divide by 2. So when I try to solve this looking at the number line, I want all the values of x that are more than a distance of 2 away from 3. That's what this is saying. So if this is 3, 4, 5 is a distance of 2 away from 5 to the right, and 1 is a distance of 2 away from 3 to the left. And we want it to be a bigger distance than 2. So we want it to be this way and this way. Because if I pick 6, anything on this interval here that's greater than 5, that's going to be a bigger distance of 2 away from 3. And if I pick, say, 0, something on this interval here, that's going to be a bigger distance of 2 away from 3. So now let's go ahead and finish solving this algebraically. So I'm going to break this up, remember, into 2 different inequalities. The first one, we just take what's inside the absolute value and keep the sign and the number on the right the same. Then I take what's on the inside of the absolute value and change the direction of my inequality sign and change the sign of my number on the right. And then I go ahead and solve each of those inequalities from there. So if I add 3 to both sides, that's going to give me x is greater than 5. And if I add 3 over here, that's going to give me x is less than 1. Now, if you notice, that matches up with what we did here, right? Everything greater than 5. And this matches up with what we did over here, everything less than 1. Now, because this is disjoint and there's no overlap, this is definitely an or statement, so we have to write these as separate intervals and then put a union symbol in between. Okay, so let's see, x is greater than 5 would look like this. Union, and then x is less than 1 would be from minus infinity up to 1, not including 1. So here's my final answer written in interval notation. Okay, next example. Again, we're going to solve this inequality, but first we have to isolate my absolute value. That's this right here. So I'm going to multiply both sides by 3 to isolate that absolute value of x minus 2. So when I multiply both sides by 3, I get x minus 2 is less than 15 away from 2. And so now I have this isolated so I can set up my 2 different inequalities. So I have x minus 2 is less than 15 and x minus 2 is greater than negative 15. I'm going to add 2 to both sides. And I've got my answer. Now, if I look at this on the number line, let's see, I have 17 here and negative 13 over here. This one here, we'll do this one in blue. This is saying anything less than 17, so open circle going this way. We'll do this one in green. This is saying everything greater than negative 13, so it's not including 13, everything going to the right. So where they overlap would be from here to here. So when I write down my final answer in interval notation, because I'm not including either the negative 13 or the 17, I'm going to write it like this. And both the negative 13 and the 17 are not included, so I need to use parentheses with both. Okay, in this example here, example 6, This is a special case. I am going to first try to isolate that absolute value of x plus 1 by dividing both sides by 2. Now, if you notice, whatever is inside here, this is why it's a special case, whatever I put in for x, even if it's some really big negative number, let's say it's negative 100. If I put in negative 100 and I add 1, that's going to give me negative 99. But when I take the absolute value, no matter what's inside there, if it's negative or positive, it's always going to be positive when you take, when you take the absolute value. So this number here should always be positive on this side because the absolute value of some number is always going to be positive. And this is saying, can a positive number be greater than negative 32? Negative 3/2. That is completely impossible. So this would be a no solution. Okay, here's another special case. If I go ahead and I try to solve this, my absolute value is isolated. So I'm just going to take what's inside there. X minus 1 is greater than or equal to 0. And then I'm going to do the second inequality where I say x minus 1 is less than or equal to negative 0. But negative 0 and 0 are the same. So when I add 1 to both sides, this is what I get. Now, if you notice, if I put that on the number line, here's 0, everything, let's do this one in blue, everything greater than or equal to 1 would be here. And then everything less than or equal to 1, let's do this one in red, would look like this. That is everything. It covers everything, all real numbers. Now, why does that work? If we look at it logically, whatever's inside here is always going to come out to be a positive because it's absolute value. Even if we stick in a really big number for x or a really small number for x with like a negative 100 or something. When I take the absolute value, it's always going to be positive, okay? And all positive numbers are greater than or equal to 0. All of those work. So my answer for this special case would be all real numbers. Everything I put in there is going to work. Versus up here, nothing I put up here is going to work because it's no solution. No matter what number I plug into this, it's never going to give me a true statement.